Hi guys. Okay, continuing on with our developer on the fly series. I guess you could call it that. FrankieV theory. I've went ahead and kind of semi-cheated and did some off-screen cooking of a player model to use as a kind of a demonstration of the differences between gender using baked player models. Now, I kind of mentioned beforehand, I believe, that putting everything onto a single unified frame is a good way of being able to maximize or optimize your development chain, as in everything running on the same frame. But I also mentioned at the time that if we changed and baked down the character, a common problem that usually occurs is the offset of some of the joints based on changes in the actual geometry that was used to create the shape. So, particularly if we're crossing over from between genders, now I have Johnny here and Min over here, obviously male, female. Both of them are identically imported onto the same frame, exactly the same way that I did Johnny here, which is then instanced off of this framework here. And of course, the body shaping is definitely different between the two of them, but the joints are relatively the same, and we didn't do too much in the way of modification to the head. So things like the eye joints and what have you kind of match up. But of course, Min here is totally different in shape and character. But to kind of have a bit of discussion here of why I did this off screen is that this particular model is a load test character, you might want to say, to kind of jump up and down on the engine to see how it will handle it. And she comes in at a total poly count of about over 400,000, 420,000. So that's almost close to 500,000 polygons just in detail alone. Now, the reason I did that, of course, is to kind of demonstrate the outer limits of what's possible as far as bringing in what would be considered studio grade character models, actors. So to kind of cross out of the video game type of idea, because the philosophy here is it's better to have too much than not enough, because you can't take not enough and make it do more. So having this amount of geometry and what have you, it gives us a huge margin to work with to bring the detailing down to where we want it to. Once we've actually looked at it inside of Unreal 4, make this design decisions as part of the development process, and then be able to make decisions that would be of benefit to the game. So, for example, we want to do some box art, if it still exists, or promo images, or we wanted to do use a 400K player model as a menu item, like for doing loadouts and what have you. An extremely highly detailed geometry and showing your best. So as a recommendation, you should always be working with high resolution, high detail assets, because you want to look good in areas where performance is a non-issue. So in this case, this could be she could be actually, we could be making a movie, and she'll animate and move fine. So we go ahead and hit play. You can see that here's Johnny doing his thing. We kind of demonstrated that before, doing the electric boogaloo. Not as if I knew what that was. And kind of illustrate the problem here, I'm going to go ahead and select our straight up mesh, and we'll select animation asset, and we'll scroll up and we'll throw on the happy dance. So now both of them are sharing the same animation that was created onto this base character, our happy dance. Remember when I brought this in over in the motion builder, we actually used what would be called determined as a franchised character or hero model, or one of the main actors we applied animation specifically designed for this character. So of course everything looks proper. But if we look at min, you can see that, as I mentioned, a problem we're going to have is with any kind of joints that are off center. So the eyes, for example, don't match up. They do match up as far as positional, as being absolute animation to Johnny, but they kind of start poking through over here, which is a rather, let's say, severe problem. So off screen, of course, to cook it up, same process I did with Johnny. I brought Min over into Motion Builder, and I initialized the characterization of this character, and when it did that, it was more than happy to accept the joints at its position and allowed the absolute animation to be retargeted to this framework. So now, after importing it, if I go ahead and select the new set here that matches up, boom, fixes our eye problem. And just for giggles, I did do some additional work, adding some animation onto it, so we have something a little bit different, so to speak. I fixed up the poke through problem. Same thing with the way I fixed up the problem with Johnny here, of making a mask that kind of eliminated it as a problem. Okay, so looking good. No weird joint deformities. We obviously have some, we want to do some cheap physics for the ponytail. Okay, as I kind of suggested, this is going to be this is an ongoing kind of project. So in another episode down the road, we'll do a cheap physics thing for the hair, the ponytail, and maybe for the arm pads, so they kind of hopefully move with the arm, that there's a collision occurs that kind of offset it. It's not going to be that much of an issue though. A couple of different ways, but if we kind of took a look around, that's it, Alt 2, Alt 3. Oh, I don't think it's going to work. Looking for any kind of poke through. I did notice the boots are single-sided materials, so you can see daylight through them. So we'll have to set that to two-sided. That's probably something we really don't need to take the effort right now to do that on screen. And it actually deforms extremely well together. So Min here was exported identically to how, and the process that was done here, and I really did it off screen because I wanted to show the comparison between the two genders and how to correct the animation problem by creating a subset of the animation. Now, we could use the same animation that we used on Johnny here, and then just quickly retarget it to this character here. So as an example, of course, that kind of demonstrates one of the benefits of Motion Builder is that you know, it's coffee and donut time as far as retargeting goes. So if it doesn't match up, we just bring them in and do a quick adjustment. But intentionally, I did not fix the T-post positioning problem properly. And as you can see, the fingers are being offset in a broken finger. So to kind of move on, to kind of fill this out a bit, let's correct that in the animation. Now, normally what I would be doing is spending a lot of time in the setting up the T-post properly and the rotations of the fingers and what have you. So they kind of match up as to what is expected by Motion Builder. As I mentioned, the thumbs are kind of pulled in, or facing up and kind of rotated in a painful position, and the fingers are kind of in a straight line, in a line with the joints, where they should be a preferred angle. It's called preferred angle. So they needed to be kind of rotated downwards. So that tells the motion builder that that's the directions the finger should rotate. So if it's pulled back too much, the reason why the tips of the fingers are going in a different direction is because the preferred angle is kind of indicated it was going to go up in the upward position. So it gives us a really weird sprawl. But it's an opportunity to show you how to use layering to fix issues like this. So let's go over to Motion Builder. Where are you? And the setup was the same as in the previous video, so I don't think there's any need to go to restart from scratch, because I have my animation down here already applied and what have you. So to fix this up, we need to we'll go over to our base animation here, and we'll add a new layer, and that would be layer 1. And then what we need to do is go in and reposition the fingers relative to the body position where the character is at the frame 0, because we're going to do a full body FK keyframes for each of the fingers to fix them up. So for example, this finger here, let's switch to local mode. We'll kind of rotate that forward. Same with that one there. To kind of get a better positional relationship to our really weird and painful bent fingers. If that happens again. Okay. Solve that problem. We're going to go with groups. We're going to go to create groups, and then we're going to turn off pick. So now we should have no, see, now I can't pick the geometry. So we should still be able to select our rotation joints. We'll select that one. Okay. Come on. There you go. Atta girl. Get that the rotation at once. So we're just kind of guessing. I would obviously spend a lot more detailing time setting the character up in the first place. So I'd take my dance sample, apply it to the storyline, and then keep working the joints until the fingers actually line up where they should be. Need a different angle. Come on, come on. What the hell? What's going on here? Okay, that's weird. I think the joints were added as part of the selection. Oh well. Don't want to spend the time just yet to fix the problem. Okay. It's misbehaving for whatever reason. Let's go over to the other side, see if we can fix this finger here, just to kind of demonstrate the fix, a possible fix. That is really weird. That it is giving me problems for being able to select that joint. Let's see if I can do it this way. Can we do the whole thing as yeah, we can. Okay, what about you? Yeah. Now you can see what happened to the thumb based on its orientation. So we're going to go ahead and select, there's the thumb up there. Oh yeah, how about you? Change the selection mode. There we go. We'll do just enough to kind of illustrate the point. Yeah, there we go. Because as part of the setup, I would also add in a few joints at the fingertips so the IK becomes active too as well, so I can pull the fingers around. But we're not doing anything fancy to that nth degree. You know, if I was setting this up for an actual game, I'd be putting in some serious time, because if you get it wrong, it will be the most annoying sound you ever heard. Okay, our tip of our thumb is like really weird. Look at that. Painful pain. Okay. Now that's actually looking a little bit more normal. And it should hopefully correct our animation problems. If it doesn't, we'll just carry on. You know, it's just as much hope and a wing and a prayer. Okay, I'm going to call that more or less done. So I need full body so I can do a keyframe. Key everything kind of idea. Okay, if I nudge this timeline, hopefully all the fingers will come back to rest position. And as we move it outwards, you can see that the fingers are no longer sprawled as much as it was. Like the thumb is still wonky. But if we put another hour into this, I'm pretty sure we can dial this in so it's absolutely perfect as far as fingers position goes. We also need to really do this with a prop like a sword or what have you. Okay. Let's let her fly and see what happens here. There you go. Okay, let it go for about halfway. Yeah, see? Not bad. Still a bit craziness going on in this finger here on this layer. We can actually fix that at this position if we wanted to. And let's go ahead and mess with it. Okay, we need FK. And we'll rotate that a bit. And we'll create a keyframe at this position. So when we move forward, it's adjusted at that frame. Okay, let's see if it's still funky somewhere else. When we come out. Yeah, see? A little bit strangeness there. Now we're just kind of watching grass grow. Sorry guys. Oh. Okay, keyframe that. At that position. And, you know, for our little experiment here, that's going to be more or less fine and dandy. We're a little weird on the finger tipping here. Should I? Yeah, what the heck. You can always fast forward, guys. Okay, keyframe there. Okay, that's great. Now we can spend even more time. Actually, actually, this is it worked out pretty darn good. Are we clipping there? Yeah, we're clipping there. Um, I would probably set up another joint for the arm for the pads. You know, if we're working this for perfection, I would give the pads an auxiliary joint so I can sort of rotate those a bit with the arm for extreme moves. Nothing beats good old-fashioned keyframing. Okay, I think we're going to call our little experiment here done, and we're going to go ahead and plot this down to our space skeleton and show you. It's also a good opportunity to show you how the source chain would normally work within a development pipeline as to being able to output and save our character animation. I believe I mentioned it at one point that I don't generally save scene files. Like once I finish all of this, I really don't save the scene file. I might, once I have all the joints corrected, I would just create a template for that particular character, so I don't start accumulating vast amounts of junk that I don't really necessarily need. Okay, so just click on it, because when we hit the button, go button here, we get a little dialog box, and we're going to save by name always. So when I hit the go button, we'll get a little thing that pops up and says, you're going to overwrite? Yes. Okay. So as the animator, anywhere in the world, I can send through SVN or whatever my updated animation files. And then on the other end, somebody would go, okay, your animation files are updated. Okay, I will re-import. Let's see if we can actually see if the corrections will pop into our hands in real time. Our little bent, broken finger there. Hit the re-import. Dremel, Dremel, Dremel. Yeah, it's going to take a bit to parse it, obviously, because it's a fairly sized file. Maybe we can talk our way through it. That's what... okay. Well, let's bring up Motion Builder here to take a look. We're almost 1,000 frames of animation. Okay, here in comes our re-import. Now we should get notification. Successfully re-import. Ta-da! See, the fingers are fixed. See how easy that is? So what did we just demonstrate as a necessity as to importance? Is that okay, see, we can see that our finger here needs a little bit more work too as well. A matter of importance is that to create a source chain. For our purposes, we don't have a source control in the ideals of what source control should be, because, well, for one thing, we're internet-based. So it becomes rather problematic if we're starting to do in-app source control. In other words, hitting this button here, connecting to the source control, checking in and checking out files, and the problem of dealing with locking files and what have you starts to accumulate. So eventually you get to a point where I gotta have access to this, and you start breaking locks anyways. So it didn't make any sense to use any kind of source control on this end, because it's actually built directly into our server system pathway. So in the ideals of backing stuff up, particularly as far as assets goes, so you know, each member of the team would obviously have a copy of whatever it is that we need to have access to as part of the actual game, which means that that the required animations, excluding the ones that are being worked on, are already in the engine. So if we need the animation, or for some reason or another, the SVN totally explodes and the hard drives melt or what have you, somebody always has a copy that can be extracted from via FBX and then use that as a backup. We also have the ability to revert, so any of the projects, and because that a lot of our projects are broken down into sandboxes, the possibility of something getting totally screwed up is minimal. So at least equal to or even better than having source control to begin with, without the pain in the ass of locking files when our team is spread out all over the world. So anyways, we've in this episode we kind of demonstrated how we can have still on the same framework a unique character from one another. Obviously Min is totally unique from Johnny here. Now if you hit the play button, okay, the fingers are actually doing the finger thing without any too much malformation that we were experiencing. And that's iteration one. There you go. See, we don't have those funky fingers facing forward in a broken pattern. That worked out pretty good. That worked out rather effortlessly. So, just like the other characters, Min here has about 200 targets. The big one. But just to drop some weight onto it, I left the mesh geometry at high resolution, so there's a 100+K right there. We still have targets. I can't see that because we're going to have to redraw the shader effect. Yeah, I won't play with the targets. You see that? You already saw that in the last episode. Now we're going to have to spend forever compiling 6,000 shaders. Thanks, guys. So here is our folder with all the different materials onto it. We can refine this down to a few, but once again, I'm demonstrating max weight, as in this is a pretty big chunk of a geometry as part of the development of the game. We want to be able to jump up and down on the engine from time to time to actually intentionally try to break something. And then in the future episode, we'll in the future we'll have some cheap physics on the ponytail. So that worked out pretty good, guys. Hey, so I think we covered enough. I'm actually quite impressed. Okay, so just so you're up and aware, in the future we will be dealing with NPCs, how to put everything onto one single amount of geometry. Oh, I forgot to mention that the other fix, of course, is when you export from Daz Studio, you should export with animation turned on, because that will give you the T-post, the main T-post positional reference as part of the export. So I don't know if I still have it or if I dumped it. So that would be this. Here in here somewhere. No, I dumped it already, because I figured I didn't need it. Okay, so we would have an animation take, single frame of our character in her reference position as exported from Daz Studio. So that's that would be the single frame corrective frame that we could put into the migration pathway to correct for the funky ass pinching of the eyes up here, caused by the joints being repositioned relative to the morph target's eyes. So if we could put that in the pathway, and then everything else after that would be an additive to that corrective positioning clip. But the easiest way is to just create new animations, quickly create animation sets, because then we can just simply use a single, because we would have to have a separate animation migration pathway for each individual character, where if we did animation sets for a particular character. Anyways, that's so you kind of see how decisions have to be made in progress. So somewhere down the road, we're going to run into an issue, or we're going to have to make a decision on which way we want to go with making custom animations for each of the characters, or making adjustments in the pathway by a single corrective pose for each of the different characters. NPCs will be totally different because everything's going to be brought in as a full form morph target, and all we do is we trigger the target. And we'll have further discussions, of course, of different directions that we will have to go with. I don't think I missed anything. If I did, I'll do a follow-up. So in the next episode, what I would like to cover is some detailing between the characters, as far as things like bringing in some eyes, doing the eyes as a realistic as we can get them. What are our options as far as that? How we can go about dealing with advanced hair shading on a material level, and basically what we're going to do is we're going to cheat. Remember, one of my mottos is work smart. We're going to download and install and the realistic asset off the Epic's marketplace, and we're going to see if there's anything out of that we can harvest. Now, hopefully in the future, if this platform, this direction becomes rather popular, I would expect to see ready-made textures and materials for generic use made available, because the same everything is matched up to the character. So the UVs that are on this character over here are the same UV maps that are on this character, and the rigging on this character is the same rigging that's on this character. The morph targets that we'll be using are the same on this character, which on this character. So as far as maintaining a standardization and a continuity between one character to another, we would only need one set of UV map templates for any of the characters, and then that would be we could use, for example, an instant material to actually optimize further our characters. So that's hopefully what we will be hopefully covering in our next developer series. As I mentioned, this is a project. This is not a how-to. We are looking for problems to solve. So if I run across a problem, I am not going to fix it, and instead show you the solution to the problem on screen as to solutions to that problem. So hopefully they won't take too much time to actually attempt. And of course, if I stop talking now, we can keep this under 2 hours and spend the rest of our day playing video games. So see you in the next one, guys. Bye bye.